Imagine a time when the world nearly lost half its people overnight. A time when the air turned cold, the skies darkened, and survival wasn't guaranteed. What caused this near-apocalyptic scenario? The answer lies in one of the most powerful natural disasters ever witnessed by our planet, a catastrophe whose echoes can still be found in the Earth, our genes, and even in the stories told by ancient peoples. Introduction. Today, our journey takes us back some 74,000 years to the shores of what is now Lake Toba in Indonesia. Back then, this serene lake was the site of a supervolcanic eruption of unimaginable power. For humanity, the fallout was profound, sparking a volcanic winter that may have led to the loss of up to half our species. In this extended exploration, we'll unravel the science, the mystery, and the human story surrounding the Toba Supereruption. We'll meet the scientists who study its legacy, explore real-life impacts on the global environment, and see how human beings adapted to a world transformed by disaster. Background: the power of supervolcanoes. What really defines a supervolcano? Unlike what we witness in recent history, these giants have the power to reshape continents and rewrite climate. A supervolcano can eject more than 1,000 cubic kilometers of material, enough to cover entire countries under meters of ash. The Toba eruption stands among the largest known, rivaling the size of the Deccan traps in India that played a role in the extinction of the dinosaurs and vastly eclipsing anything in recorded human history. Expert interview. Dr. Lisa Trent, volcanologist, University of California. A supervolcano is a rare but catastrophic geological event capable of ejecting more than 1,000 cubic kilometers of material in a single eruption. These eruptions are far more powerful than typical volcanic eruptions and can cause massive destruction on a global scale. The consequences for global climate and life are profound. Sulfur and ash are propelled into the stratosphere, forming a haze that blocks sunlight and leads to significant drops in temperature worldwide. This phenomenon, known as a volcanic winter, can disrupt ecosystems, agriculture, and human life for years or even decades after the event. Historical context. Supervolcanoes have played a crucial role in shaping the Earth's landscape, atmosphere, and ecosystems, leaving behind both destruction and creation in their wake. One of the most well-known examples is the Yellowstone eruption, which occurred 640,000 years ago. This massive event created enormous calderas, altered the geography of the region, and disrupted global wildlife through the release of volcanic ash and gases into the atmosphere, which likely influenced the climate for years. Similarly, the Taupo eruption in New Zealand, approximately 26,000 years ago, was so powerful that it sent ash clouds as far as Antarctica, showcasing the far-reaching effects of such phenomena. However, the Toba eruption, which took place around 74,000 years ago in present-day Indonesia, stands out as one of the most catastrophic events in Earth's history. It is believed to have caused a volcanic winter, significantly dropping global temperatures and possibly contributing to a bottleneck in early human populations. Traces of the Toba eruption's ash and effects can be found across nearly every continent, marking it as an unparalleled event in both the fossil and geological records. These supervolcanic eruptions serve as a reminder of the immense power of Earth's natural systems and their ability to shape life on a global scale. The eruption. What happened at Toba? Toba's eruption began with a series of violent earthquakes as immense pressure built up beneath the Sumatra landscape caused by the movement of magma deep within the Earth. The ground fractured and split open, unleashing a catastrophic surge of molten rock, gases, and ash with a force comparable to millions of nuclear bombs detonating simultaneously. The main eruption, which scientists estimate lasted around 2 weeks, was one of the most powerful volcanic events in Earth's history. However, its impact lingered for years, shaping the planet's climate and ecosystems. The eruption expelled an estimated 2,800 cubic kilometers of material, an unfathomable volume, enough to bury the entire state of California under 3 feet of ash. Thick ash clouds spread across the Indian Ocean, dimming sunlight and drastically cooling the planet. Meanwhile, pyroclastic flows, searing waves of gas and rock traveling at hundreds of miles per hour, obliterated everything within a 60-mile radius, leaving a barren, lifeless landscape in their wake. This supereruption was so massive that it may have had global consequences, including a volcanic winter that could have threatened early human populations. Reenactment segment. Actors portraying early humans witness the sky turn to midnight at noon. Plants wilt under falling ash, Animals scatter or perish, rivers clog with debris and dead fish. Historical facts. Geological cores from the seabed and lakes in India and Africa show a distinct layer of Toba ash, sometimes over half a meter thick. This is physical proof of the eruption's worldwide impact. Expert commentary. Professor Rajiv Krishnan, geologist, Institute of Earth Sciences. Seismic evidence and ash deposits show us the scale of destruction. Lake Toba itself is the remnant of the collapsed caldera. What we see today is only a shadow of the explosion that shaped it. Global effects, the aftermath. After the eruption, Earth entered what is known as a volcanic winter, a period of significant cooling caused by volcanic ash and sulfur particles lingering in the atmosphere. These particles formed a thick haze that blocked sunlight, drastically reducing the amount of solar energy reaching the surface. As a result, average global temperatures likely dropped by 5 to 10 degrees Celsius, causing widespread climatic changes. For context, the last ice age, which profoundly reshaped ecosystems and human life for thousands of years, was triggered by just a 6 degrees Celsius temperature drop. This sudden and dramatic cooling would have impacted agriculture, animal populations, and entire ecosystems, ushering in a challenging period of adaptation for all life on Earth. Real-world example. Mount Tambora's eruption in 1815 caused devastating global effects, including widespread famine, disease, and significant loss of life when the Earth's average temperature dropped by just 1 degree. The massive ash cloud ejected into the atmosphere blocked sunlight, disrupting weather patterns and leading to what became known as the year without a summer. Crops failed, livestock perished, and communities struggled to survive under unrelenting food shortages. Now imagine that catastrophic effect multiplied many times over, as was the case with the super-eruption of Toba tens of thousands of years ago, which is believed to have caused a volcanic winter that threatened the survival of the human species. Crops failed, animals perished, and water sources became contaminated with falling ash. Scientists have found evidence of abrupt changes in pollen grains and megafauna fossils, matching the timing of Toba's fallout. Historical context. Analysis of Greenland ice cores reveals sulfur deposits dating back to the Toba Supervolcanic eruption approximately 74,000 years ago, proving that its impact was so massive it reached even the polar regions. This event likely caused a volcanic winter, significantly cooling the Earth's climate. Meanwhile, archaeological sites in India show an abrupt shift in tool-making traditions during the same period, indicating a dramatic disruption in human life. This suggests the eruption triggered widespread social and environmental upheaval, influencing cultures and ecosystems far beyond its origin. The world's population of humans and animals was forever altered by the Toba event, a massive volcanic eruption that occurred roughly 74,000 years ago. This catastrophic event caused dramatic climate changes, plunging the Earth into a volcanic winter that lasted for years. Many species disappeared from a fossil record, unable to adapt to the sudden and extreme environmental changes. For humans, the Toba event was a crucible that tested our very survival, with some researchers suggesting our population may have dwindled to just a few thousand individuals. Against incredible odds, humanity endured, shaping the course of our evolution and resilience. Evidence and research, pieces of the puzzle. How did researchers connect these dots? By carefully analyzing evidence buried in the Earth. Volcanic ash, often described as a natural timestamp, provides critical clues. In India, archaeologists discovered thick gray layers of ash deposited above ancient human tools, offering a clear timeline that shows humans lived in a region both before and after the massive Toba eruption. Over in Africa, sediment cores extracted from lakes reveal signs of a sudden cooling event, alongside shifts in vegetation patterns, both tied to the aftermath of the volcanic explosion. Even in Malaysia, researchers identified ash layers with chemical signatures uniquely linked back to Toba, reinforcing its far-reaching impact. These findings, pieced together from diverse locations, help scientists understand how this catastrophic eruption shaped environments and human survival across the globe. Scientific insight. Geneticists have traced human ancestry by analyzing mitochondrial DNA, a type of genetic material passed down from mothers to their children, collected from people across the globe. Their research revealed a fascinating discovery. Around the time of the Toba volcanic eruption, which occurred approximately 74,000 years ago, the human population experienced a dramatic decline. Estimates suggest that numbers fell to as few as 2,000 to 10,000 breeding pairs, a phenomenon known as the bottleneck effect. This drastic reduction in population size likely had a profound impact on genetic diversity, which is why humans today are genetically much more similar to one another compared to other primates, such as chimpanzees or gorillas, who exhibit greater genetic variation. This finding illustrates how a single catastrophic event may have shaped our evolutionary history. Interview segment. Dr. Amina Oduro, genetic anthropologist. By examining the DNA of modern human populations, scientists have uncovered evidence of a significant genetic bottleneck in our history, a period when the human population drastically declined. This bottleneck suggests that most humans alive today are descended from a much smaller group of ancestors who managed to survive this challenging time. Researchers estimate that during this period, the effective breeding population may have dropped to fewer than 10,000 adults worldwide, potentially due to severe environmental changes, natural disasters, or other catastrophic events that threatened humanity's survival. Controversy and debate. However, not all evidence supports a catastrophic collapse occurring everywhere. Modern research conducted in regions such as Southern Africa and India has uncovered human tools above the Toba ash layer. These tools appear to have remained largely unchanged, suggesting that some populations were able to adapt and survive despite the harsh environmental conditions caused by the Toba Supereruption. This survival may have been possible due to the presence of refuges in areas less affected by the worst of the extreme cold, starvation, and other challenges, allowing human communities to persist and even thrive in isolated pockets. Scientific debate. How deadly was Toba? Was the Toba Supervolcano truly an existential threat to humanity? The eruption, which occurred about 74,000 years ago, was one of the largest volcanic events in Earth's history, releasing massive amounts of ash and sulfur dioxide into the atmosphere. Recent climate models suggest the picture may be more nuanced than previously thought. While some regions experienced catastrophic environmental collapse, leading to widespread extinction and severe challenges for early human populations, others remain surprisingly habitable. Factors such as local geography, regional climate conditions, and innovative adaptations by early humans, like changes in diet, shelter, or migration patterns, may have played a crucial role in their survival. This complexity challenges the notion of a uniformly devastating global impact. Expert panel discussion. 3 scientists with opposing views debate the numbers. Dr. Thomas Evans. The severity of population decline is clear in mitochondrial DNA, but regional variations suggest uneven impacts across the globe. Dr. Sarah Bacco. Archaeological finds show persistent human adaptability. Even in the shadow of catastrophe, people found ways to survive. Dr. V.J. Nair. Recent climate models indicate that while the Toba eruption was world-changing, it may not have caused total collapse. Instead, it was likely a deadly challenge that helped spur innovation and migration. Scientific insight. New research from South Africa, for instance, reports no drastic change in tools or dietary patterns at sites spanning the eruption, hinting that not all humans face the worst conditions. Impact on human society and evolution. The Toba catastrophe may have changed not just who survived, but how we survived. Evidence suggests our ancestors may have been forced into close-knit groups, fostering greater social cooperation and innovation. This is when some experts believe critical advancements, language, symbolic thinking, and more effective tools accelerated. Anthropological analysis. Human society evolved rapidly in the aftermath. Small mobile bands would have been best suited to endure shifting weather and scarce resources. Population bottlenecks like Toba's reshaped genetic diversity, concentrating traits that proved adaptive under extreme stress, resilience, cooperation, creativity. Real-world context. Look at today's population. All 8 billion of us share remarkably similar DNA, more so than chimpanzees from a single region. This points back to an event, like Toba, that nearly erased our variability in one swoop. Real-world examples, volcanoes that changed history. Toba wasn't the only volcanic disaster to shake the world. Human history is repeatedly marked by eruptions that brought dark days. Mount Tambora, 1815, triggered global famine and killed over 71,000, the worst eruption in recorded history. Krakatoa, 1883, its explosion killed over 36,000 and generated worldwide climate anomalies. Pinatubo, 1991, lowered global temperatures for several years, proving how even small Eruptions can disrupt the planet. Mount Vesuvius, 79 AD, produced the world's most famous archaeological site in Pompeii, a city frozen in tragedy. Each of these events left marks in ice, tree rings, and human memory. Together, they help us imagine, just faintly, what the world after Toba was like. Toba in human memory and myth. Could echoes of Toba survive in our collective memory? Flood myths, tales of darkness, and legends of fire from the sky are found in dozens of ancient cultures. In Indonesia, the Batak tell of a fiery mountain that destroyed life, while African tribal stories speak of famine and sky-darkening ash, possible faint echoes of this deep, ancestral trauma. While not direct records, these tales reflect humanity's intimate relationship with the natural world and the terrifying power it sometimes unleashes. Implications for the present and future. Toba is a story not just of a distant past, but of our future. Today's supervolcanoes, Yellowstone, Taupo, Campi Flegrei, and more, pose challenges for modern society. Scientists use satellite technology to monitor tiny ground movements and gas venting. International agencies map hazards and plan global responses. If a Toba-sized eruption occurred again, food security, international trade, even global peace would be tested. Expert interview. Dr. Javier Morales, disaster preparedness specialist. If another super-eruption were to occur, it would challenge the modern world's infrastructure, food systems, and economies just as it once tested our ancient ancestors. Preparedness, global cooperation, and adaptability are critical. Historical insight. In 2010, volcanic ash from Iceland's Age of Geological closed European airspace for days, stranding millions and costing billions. And that eruption was a tiny blip on Toba's scale. These modern examples show that even small eruptions can disrupt our connected world. Conclusion: survival through resilience. In the aftermath of Toba, humanity's story is one of survival, not because we are immune to disaster, but because we adapt. Against incredible odds, our ancestors endured. By learning from Toba, we remember the cost and the necessity of resilience, curiosity, and community. Toba's shadow stretches forward and back through history, reminding us of our shared vulnerability, but also our shared strength. Every day, we write the next chapter in humanity's story. If you're fascinated by stories like this, don't miss out on more. Hit subscribe and join us as we uncover the untold chapters of Earth's history and what they mean for our future.